Hello, I Dr. Pankaj Kumar Goswami welcome you all again in the machine learning using Python tutorial series. In the previous lectures and the previous tutorials, we have learned so many libraries and their applications. In this video, I'm just going to work with a very interesting thing that are really useful. Those are studying, those are creating their analysis, those are working the research area, those are working the industries. Some small tools applications are here that are just going to be very useful for all those are related with somewhat data science. So let's begin this. So those are new in this video, so I'm just making them clear. Please start working with the Google Colab option. If you don't know how to start it, so you may go to the previous video. Just type in a simply Google in a Google Colab. This kind of a file will be open. So this Colab section will be there, and start with your connection. So if you find any difficulty, you just please text me. I'll help you out. So in this video, what we have a target to find out the real-time examples related and the help of the Python, how we are just going to solve all of them. Let's see how the SciPy is going to solve your small mathematical issues very easily. So I'm just taking one example here. I'm just simply calling my SciPy dot spatial import. I'm importing a very simple function which is cbrt. It means cube root. So I'm just going to find out the cube root of how you can go for see this, taking the variable as cb, calculating cbrt of a value I've just taken here, $27 and let's say 64, and I'm gonna to print this one. So see here, I'm simply doing a very simple exercise here. I have two numbers 27 and 64 using SciPy library special import cube root, and see here I'm gonna to print it, and let's see what is the result of. So see, the 2764 is available here and it's immediately giving an option. This is what a strength of Python. So if suppose you increase any one more, like here, let's say I'm just taking the 125 also and doing this one. So it is helping you. So if you have a large data set values over there and you are looking only for to find out the cube root of this, so how much it is has become. It's so great. So similarly, another issue is there, like if you're looking to find out the exponent of some number, so you may go easily like that, just copying this one that I have copied, putting up here, only changing one thing because I'm seeking to find out the value to get the exponential. So I'm just taking this x10, it means the exponential for the 10 in base of 10 system, and let's say I'm just choosing up some variable as exp equals to and try to find it out, exp of 10, and taking two different values. Let's say I'm just taking one, another is to be taken as 10, and simply gonna to print this one. And running it out. See, you have an answer. So this was a simplicity of this one. Taking another example. So many times you try to find out the permutation and combinations, that always becomes so tough. I'm just copying this one, creating only one change. Now it is a combination I'm looking for. So what combination I'm looking for, I'm just giving its value. So looking for combination of, giving this value com. Now for what, 5, 2, and defining all these attributes. So exact, do you want this exact value or the true value? So you have to go for false. repetition, because it may be possible number of times the repetition may be go. Yes, you want repetition. Is true. That's it. Now simply I'm gonna to print this one. Print of com. So let's check it out. So now, well, this is a 15 value, so you may change your values and find out your results. Suppose that you have a very tough values like something 10 and try to solve now. It's a 55. So this is exactly a very simplicity of the function. Let's go for more. Try to find out one more. This is a permutation. I'm copying this one, and instead of this, right now I'm just giving only the simple value. It's a permutation, and then defining this perm of calculating this permutation, and you may define it's 5, let's say 2, not doing any attribute else here, simply going to print this print of per. So let's see. So well, the value is here. So ultimately this is another very high simplicity of this function, not creating any sort of a formula, not just driving the equation directly, just putting the value, importing the library, and this library is going to help you so nicely. Taking another example of the linear algebra, I'm just copying this again, and from the SCI, now this time not just taken from the special function, we are just simply taking the SciPy and importing the complete library of linear algebra. So here I just call this library of linear algebra, and I'm just defining a matrix. Any matrix I'm just taken. Example, creating this np torch array, and let's see this I'm going to create. So the first value I'm just choosing, this is the 4 comma, it's a 4 comma 5, and in that the second I'm choosing up 3 comma 5. So now that's all, it's completed. If you want to check what is your array, you may print it all, print, and you may print m and may check what is an output. So it is basically a 4 3 5 5. This kind of a array has been created in the form of a matrix. Now I'm going to use the linear algebra, and using its script try to find out the inverse, and what the name I have just given, this is the basically m. So this time I'm going to create this one. So I'll have this 4 5 3 5. Now the basically the output is nothing else 1 minus 1.6.8. So inverse has been created just in a second. Similarly, moreover, you may have so many options, so many attributes related with the matrices. So creating the eigenvalues and eigenvectors you can easily go for, simply looking for the Bessel's function in the integration and differentiation, so on. Taking one more example, of very simple example of creation of a Fourier transform. Generally we need to have some spectrum representation of some different kind of a signals. There it is always required. So let's begin with me. For the same, I'm starting creating one more. So first of all, important part is here, I'm just calling up this library using a simple function. First of all, whenever we are just going to plot something, it is required to call matplotlib import pyplot as plt. So that I have just called up. Because I'm going to work with the NumPy arrays, so that's why I'm importing NumPy as NP that I have called up. So well, let's design a simple equation. So I'm just designing a frequency, let's say it's 5, then designing a sample rate. So SR, it is basically to be taken as sample rate, that I have just taken as, suppose, an example 50. Then after, I'm just going to design basically the time structure. So how it is going to work? So np dot creating a linear space. So linear space has been created. Forward values, I'm starting from it 0, 2 and creating a space of 2. That is what the spacing. And what I just created, frequency. On that basis, it is going to create. Is there any endpoint? So that will be created. So on this basis, I'm just going to create this one. Then after, I'm designing its amplitude. So amplitude means the main equation can be easily calculated using a NumPy array dot sine. And what frequency we have? F. That I have just created, creating a string to np dot pi. We have to take care about this one. A simple equation is here, and we have created this t. The 2 pi ft is a simple equation, always we go for that, and here we have to take this because creation of this sample of t, so that has been taken as SR. So now that is created. So far I am going to start with this figure, comma axis. On basis of this two, I'm going to plot dot subplots. You may set your axis dot plot t comma a that you are going to print. So you may add your title and something else. I'm not going to do this right now. And plot dot show. Let's see what result we get. So while checking this one, oh fine. So basically here a particular sinusoidal waveform has been created. This is a function is basically in a time domain, and I'm having this function. Now let's move on to the next. So now from the pack of basically SCI, I'm going to call up the fast Fourier transform, and let's see what kind of result I'm going to get here. Creating a new line, and I have copied. So from SciPy.special, right now it's not only the spatial, this is only SciPy. I'm importing FFT pack. Simple. So I'm just simply importing FFT pack and creating, let's say, magnitude this A FFT pack. Dot up. Now from FFT pack we have options to call. So I'm just calling this one small a amplitude of this FFT. Now choosing a variable for this one, that frequency, equal to FFT pack dot. So the first I have just chosen the basically the amplitude. Now I'm choosing the frequency. FFT. This is the script for this one. For what I'm looking for calculation of this length of A. Whatever the length of the A is here, it will work upon that. And this whole section is going to be multiplied with what? What I have just taken as a frequency sample. It means SR. Is going to multiply with this one. Now the next target, we have figure, comma, axis. We are gonna to plot dot subplot so first of all axis dots 10. I'm taking the two factors frequency comma np dot abs. So absolute value of A I'm looking for. So that will come on this one. I'm not going to set any axis title and labels that you may create as your own one. You may set. So I'm going to plot this one to make you able to show this. Plot show. Let's check. So I have just created I just created a simply calling this FFT pack. So taking a FFT of amplitude, taking the FFT of fast Fourier transform of the frequency and axis, and plotting it is all in the absolute value with respect to that, and let's see what results come up. So let's run this program and check what is. Wow, that's so nice. So now you have gone through simply a spectrum. That the spectrum shows where you just have the peak. So you are just having a one negative axis, one positive axis on what basis, and on this respect to the absolute values you have such kind of a spectrum. And we all know that if we have a sinusoidal function, so we cap basically about the zero axis, it is a symmetrical spectrum comes up like that. So this is a spectrum we got up here. So this is exactly a beauty. Writing only two or three code lines, we are easily able to find out a spectrum of any function, any signal. It's a wonderful mathematical aspects of Python. Taking one more simple example, generally we know that integration and the differentiations are the tools of every science. So whenever you're working with these kind of a science, always it requires. So sometimes it has become very much typical to find out the long integration values. Here your Python is helping in this way also. So let's begin this one. So I'm just copying this one, not taking this special, simply finding out the SciPy and importing. It's one of the inbuilt function integrate. I've called this one. And then after I'm just taking an example, suppose that. So what exactly you need for this? You need definite function and its limit. We are defining all this one. Let's say we have any function of something. I'm defining f equals to lambda x. So this is basically a function I've just decided and has values x square. So this shows you the squaring. I have created the one function and then choosing up the limit. You may choose your limits in which we are looking for. So simply giving integration, simply giving this integration equals to integrate dot quad. What you're going to integrate? I'm going to integrate this one f with respect to the limit of 0 to 1, and then after I'm going to print this. print of integration. Let's check this result. That's so nice. You may change this attribute also. Rather than creating this one, you may simply have an x or 2x, or finding out only the single x value. Let's check how does it work. So it has basically this value from our values 0.5, this one. So you may create your own values, you may create your own different function, anything that you want to do that. So this is simply helping you to find out the integration of your different aspects. Simply you can go for the differentiation as well. It has a library. So ultimately I wish to tell you, like, so many attributes, mathematical attributes are there, in which you can have a really special kind of a function, algebraic function, interpolations, optimization, stats, numerical integration. So many things are there that you can easily go with this. So this is ultimately a playing with Python, playing your mathematics using Python. This is a very simple aspects. So I hope so you all might be liking this video, and now you're really able to go for more mathematical tools and applications. Till then, thank you very much. Bye bye. In the next section, now soon we are just going to work to find out the core deep science of machine learning. Till then, thank you. Bye bye.